Take it away, Gordon.
Hey. All right. Hello, everybody. I'm Gordon Rosner, the president of the East Valley Astronomy Club. And here we are on our Friday, the 20th August virtual general meeting. So first off, on the agenda, we'll have a welcome, and then we'll go into introductions as always. Now the format is has been the same every month, so we've been sticking with that. I have some introductions of the club leadership team, get into club news, which there isn't very many because of obvious pandemic concerns. But we'll talk about officer elections that are coming on up. And then we have a member presentation by Adriana Baniecki. And then we'll go into our main presentation by Helen Friedman. So, welcome everyone. As usual, hope you all can live long and prosper. This is the introductions to the leadership team. So up here, the president, vice president, treasurer, secretary, they are the administrative officers. And then the board members at large are listed down there. That makes up the board of directors, that column on the left. The administrators are those who are not elected, but they're assigned to do various jobs, various needs in the club. But you can see the property administrator is still open. So that person is see requests, questions about equipment, that do we want the equipment, they want to donate stuff to us. And what this person does is determine whether it's appropriate for us. And if it is, would go and check it out. And if everything is okay, then we'll pick it up and bring it back to our shed that we have by our Greco Observatory. And then that equipment generally finds its way to educational institutions, schools, things like that. Or whenever we have an auction, anything that's left over, we put up for auction. So that position is open. Anyone interested, please let me know. Club news are, again, the club same old thing, people. Greco remains open for the private star parties. You know, there's small groups, less than 6. Generally, they're like 2 or 3. The Greco is our observatory that's in Gilbert, Arizona. And therefore, right now, it's for private viewings only. So we're not open up to the public yet. All other EVAC personal contact events still remain canceled. Wow, we thought we were on the verge of getting ready to open back up again, but then the Delta variant hit and we got kicked back into not knowing exactly when we're able to open. So still no events, still don't know when we're going to open. And our member presentations, if you're interested, get a hold of me via the website. There's a president link right there. And a very good example of a member presentation will be given today by Adriana. Member articles, again, Adriana gave us a really good newsletter article for this month. So take a look, make sure you get in that newsletter, check out Adriana's article and see a very good example of how members can give articles into our monthly newsletter. And remember too that, of course, these are being recorded. Officer elections, now it's not going to happen until, things aren't going to happen until October, but it's time to really start thinking about it. All the leadership team positions are open. They're listed there. Because remember that the leadership team that was in place decided to, with general membership agreeing, that we would continue in our current positions for another year. So all of them are up again. And nominations, if you're interested in any of these, great. Next year, hopefully, I don't see why not, but we'll be opening up and hop into one of these leadership positions and get us back on track the way we were before. And of course, the previous administration, the ones currently that I introduced, of course, would be helping you out. Fun things, leading the club and making sure everything is going okay with it. The nominations will be open during the October general meeting, and they'll only continue for a few days. So start thinking about if you want to do it, because on the October meeting, I'll say, okay, if you want to run, let me know, because it's only going to be open for a few days, because we want to get the list in the November newsletter so that everybody can be aware of the nominations, and then they can vote during the November meeting. So our next EVAC meeting, Friday, the 17th of December. Main presentation will be by Dr. Nathan Williams of NASA and JPL. So we'll be talking about the Mars helicopter. So be sure to put that on your calendar. Member presentation, Adriana Baniecki. I'd like to introduce her. Again, she was the one that gave us a member article for the newsletter. So you've probably already been introduced to her. But I will hand it over to her. Adriana, do you want to share your screen?
Yes, I can do that. Let's see. All right, does everything look okay?
Looks great.
Sweet. All right, hi everybody. My name is Adriana Baniecki. I'm a high school senior from Chandler, Arizona. I've been pursuing amateur astrophotography since January 2019, and I joined EVAC last summer. And I'm super excited to have the opportunity to present here tonight. I'm going to be talking today about my experience at this past summer at the Advanced Astronomy Camp. This camp is run by Dr. Don McCarthy through the University of Arizona, but this year with COVID, it happened to be virtual. If you're a high school student, just really quickly, or if you know someone who is a high school student who might be interested, I've included the application link for the camp on the bottom of the slide here. The goal of this camp is to allow high school students to use the 24-inch optical, 32-inch optical, 10-meter, and 12-meter radio telescopes at the University of Arizona in order to conduct their own individual research projects. During the morning and the afternoons, about 30 other campers and I heard lectures on different astronomy and astrophysics topics. And then during the evenings, we were able to use the telescopes to pursue our own research. I had the chance to participate in 2 different research topics. The first one, Gord mentioned, I was able to write about for the newsletter. But this one, I'd like to talk about the second topic, and that is stellar distribution across different galaxy types. A quick aside before I dive into the project, there are 2 really bright images on the right side of the screen here. The image on the top is the Spiral Fireworks Galaxy, and the image on the bottom is the Spiral M106 Galaxy. I have some additional beautiful color images kind of sprinkled throughout the presentation, and while they are lovely, they're actually not the goal of this project. The goal was to map red and blue stars across different types of galaxies in order to draw scientific conclusions about the age and behavior of each galaxy type. Now, that's a lot to unpack, so we can kind of break that down a little bit further. We imaged each galaxy using the 32-inch optical telescope and captured the red and blue filters separately for each galaxy. We know from the Hertzsprung-Russell diagram that old stars are red and young stars are blue. And this is simply because as stars get older, they use up their fuel, they burn dimmer, and they can't emit that energetic blue light anymore. So they just kind of glowed more dimly and red. We processed each the red and the blue filters individually and separately using the AstroImage-J software. And we examined 6 different types of galaxies: spiral, elliptical, dwarf, sunburst, or starburst, merging, and irregular galaxies. So the first type of galaxy that we observed were the spiral galaxies. And we were able to observe 4 separate spiral galaxies: the Firework, Whirlpool, Pinwheel, and M106. In all of these galaxies, the core central mass of the galaxies glow brighter in the red filter than in the blue filter. And all I mean by the term brighter is if you take a look at the fireworks galaxy in the top left, we can see that the red center just appears brighter on the screen than the blue center does. And this means that at the center of the fireworks galaxy, the red stars there are emitting more light than the blue stars at the center of the galaxy. And so we can conclude that there are more red stars than blue stars at the galaxy's center. By contrast, the dusty spiral arms of all of these galaxies actually glow brighter in the blue filter than in the red filter. A really good example of this is actually M106, which is in the bottom right. The blue image's spiral arms are simply whiter and brighter on the screen than in the red filter. And thus we can conclude from both of these that spiral galaxies tend to have old and stable red cores, and the spiral arms rotation can encourage new star formation, which glows in the blue filter. The second type of galaxy we observed were the elliptical galaxies, known for their rounded or elliptical shape. We were only able to observe one, which was NGC 5813, but it was still quite interesting. Both this blue and red filter were processed at the same scale, as noted by the 3.48 arc minutes little bar across the top of the images. And both images depict a uniformly glowing galaxy. And thus we can conclude that the red stars and the blue stars in an elliptical galaxy are uniformly distributed, first off. But second, we notice that the galaxy is bigger and brighter in the red filter than in the blue filter. And thus we know that there must be more red stars in an elliptical galaxy than blue stars. And thus our team concluded that elliptical galaxies tend to be on the older side of galaxies. The third galaxy type we observed were dwarf galaxies. We were able to observe two different dwarf galaxies, M110 and M32, both of which are satellites of the Andromeda Galaxy, which is a near neighbor to our own Milky Way galaxy. Like the elliptical galaxies, these galaxies glow evenly and uniformly in the red and blue filters, so we can conclude that the stars are evenly distributed. And also, like the elliptical galaxies, the red filter glows brighter and bigger than the blue filter. So we can conclude that dwarf galaxies are largely populated by red stars, which make them older galaxy types. The fourth type we observed were starburst galaxies, which is actually a galaxy type that I didn't even know existed until this camp. So that was pretty neat to learn about. Starburst galaxies are galaxies that are literally bursting with all of the new star formation that is happening inside of them. In the cigar galaxy, we notice that the brightest parts of the red and blue filter are along the cigar-shaped center of the galaxy, indicating that both old red stars and new blue stars are forming and circling around the galaxy's center. Additionally, the red filter wavelength is actually closest to the infrared wavelength of infrared light, which usually depicts the presence of glowing gas and dust, which we know means that there's an active stellar nursery there. These same stellar nurseries just produce lots of brand new stars, and they actually are the ones that are producing the bright stars that we can see in the blue filter. So these two images kind of work together to tell the same story, which is always good. And our team is confirming that starburst galaxies are rapidly churning out these brand new stars. The fifth type of galaxy we observed were merging galaxies, or two galaxies that are in the process of fusing together and colliding to form a brand new galaxy. It's important to note, though, that in every merging galaxy system has its own set of unique variables, right? All galaxies have different masses, they're colliding at different speeds and different angles, etc. And each one of these galaxies, ARP220, NGC 6052, and the mice galaxies, all do look slightly different, so that makes sense. But something they do all have in common, however, is that the central knot of the galaxies glows brighter in the red filter than it does in the blue filter. A really good example of this is NGC 6052 in the bottom left. This means that even through these violent mergers, the cores of the galaxies can still stay relatively intact as compact and stable knots. In certain cases, such as the mice galaxy on the right, we can see that this calm interior does not extend to the exterior. The tail of one of the galaxies, which streams from the bottom to the top in one of these images, indicates that active stellar nursery gas and dust in the red filter and new stars in the blue filter indicate that that system is not stable. So the outer reaches of the galaxies are bursting with the new stars that can happen from these tidal sort of galactic collisions. The sixth and final type of galaxy that we observed were my personal favorites, the irregular galaxies, just because they can't be easily classified. There's no sort of broad system that you can use. On the left, we have the Tadpole Galaxy, which is a very faint galaxy kind of on the right of center of the images. It's one of the farthest away galaxies that we observed, and it glows the brightest in the red filter. And these two facts kind of work together to reinforce each other. Since it glows brighter in the red filter, it means that the galaxy is more stable and populated by older, redder stars, which makes sense because the galaxy is farther back in the universe and farther back in time. And also just something to add, all I mean by stable is that all of the dust that would normally go into forming new stars and would be visible in the blue filter are currently all tied up in the old red stars. So they can't produce any new stars, no big galactic changes, and so the galaxy on the whole stays pretty stable. The hockey stick galaxy on the right could not be more different from the Tadpole Galaxy. It actually glows brightly in both the red and the blue filters, both around the center and in the galaxy's tail. And the presence of hot blue stars at the galactic center tells us that the hockey stick galaxy is being ripped apart by some force currently, and that roiling sort of turmoil is manifested through the production of these hot young new stars. I realize that might be a lot to take in a kind of a short time, so I just want to summarize all my team's findings in this table. So first off, we had the spiral galaxies, like the whirlpool galaxies. They had old galactic centers, but active star formation in their arms. The elliptical and dwarf galaxies, like NGC 5813 and M110, have a uniform distribution of old red stars, which allow us to date them both as older types of galaxies. The starburst galaxies, like the cigar galaxy, are bursting with red glowing dust, indicating that they're undergoing rapid star formation. The merging galaxies, like the mice galaxies, even though they were undergoing dramatic collisions, still had old and preserved cores and crazy star formation around the outer arms. And the irregular galaxies really did live up to their irregular names, as they were either old and stable, like the Tadpole Galaxy, or being ripped apart, like the hockey stick galaxy. And on the left side, we have two more of the amazing color images. The one on the top is the Whirlpool Galaxy, and the one on the bottom is the Starburst Cigar Galaxy. To conclude my presentation, I'd just like to extend special thanks to Dr. Dawn McCarthy and the entire U of A Advanced Astronomy Camp staff. I'd like to especially thank my 5 teammates for working together on this project. A lot of the observing sessions were until 4 and 5 in the morning, and there's no way one person could have done all of that by themselves. Definitely takes a great team to get all that work done. And finally, I'd like to thank Gordon and Tom for giving me the opportunity to present here today. The two final pictures on this slide are the hockey stick galaxy on the right and on the left, excuse me, and the Tadpole Galaxy on the right. And thank you so much for your time, and I'd like to open it up for any questions.
Thank you, Adriana. One question, were the observations done with the radio telescopes or optical?
All of the observations in this project were done with the 32-inch optical telescope.
Okay, thank you. Any more questions? Don't be shy.
Right.
Ask away. Okay, let's see. Okay, Bob put one. Okay, Tony George, were the exposure times equal for both filters?
Yes, so we ended up taking, I believe it was 4 images per filter, and each exposure time ranged from, I think the lowest we had was about 2 minutes to 10 minutes. But for each of the galaxies, we made sure to use the same exposure time for the red and blue filters when we compiled all of the pictures.
Okay, and let's see, I think I caught a question in the chat. Make sure you put it in the Q&A session, just so I don't miss it. From Bob Buchheim. Did you try to make a map of the B-R color? It says he worked with a student who tried and it was really hard to do. So he's just wondering if your team plotted that.
Yeah, that would have been really nice to try. Something we were hoping for was maybe a little bit more of the scientific data. Well, only thing we got back were the pictures, so we just had to kind of qualitatively analyze this. But that definitely sounds like a neat project.
Let's see. Okay, another one in the chat. Aren't blue stars inherently brighter than cooler red stars of the same size?
Yes, yeah. And so that was something that, let me actually go back a couple of slides here to the elliptical galaxy. So yes, that was something that made the elliptical galaxy kind of all the more interesting to look at, was that blue stars are generally brighter because they're emitting at a shorter wavelength than the red stars. So whenever the red filter was so much brighter and bigger than the blue filter, it really meant there had to be a lot more red stars than blue stars in that galaxy. So it was really neat to see that.
Okay. Let's see. Yeah, you're getting a lot of kudos and great jobs. And a couple more questions. One, are you going to major in astronomy?
I am not. I'm thinking about majoring in physics, but definitely keeping astronomy as a very, very good hobby because it's super interesting.
Yeah, physics is a great stepping stone to a lot of different areas. Let's see, one more. Were the density of both filters the same? It appears the blue filtered photos were very dense/dark.
Yeah, so I'm actually not familiar with the term density. I know whenever we were processing the images, we tried to process them at the same brightness to try to correct for any, something that might have been brighter just because we processed it at a brighter level, I guess. But I'm really not sure about the term density.
Yeah, I think he's meaning is the fraction of light let through that particular wavelength range the same for both? Like, were they both at 94% or?
Yeah,
probably, because I don't think one would be at 95 and the other at 66.
Yeah, I would think so, but I'm not 100% sure.
Okay. All righty. Let's see. Okay, so so in the chat, there's a chat message for you, Adriana, if you want to explore that. Bob is willing to lend a hand.
Okay. Oh, gotcha. Perfect.
Okay. Alrighty. I think that should wrap it up. Thank you very much, Adriana. That was a wonderful presentation.
Thank you. Thank you all for letting me have the opportunity.
Cool. It's our pleasure.
All right. Yeah. Yeah.
Oops.
Thank you, Adriana, very much. Very nice and interesting presentation. And people, hey, that was a great example of a member presentation, and especially from one of our young amateur astronomers. So use her as an example. She had a great format. Boy, that one that looks like a notebook, that was something new. I enjoyed that. It almost looked like it was your notes taken during it. So yeah, great presentation and excellent example of a member presentation. And I'm sure we will be seeing more of Adriana in the future, or at least I hope so. All right, I'll give it on over to Tom, and he'll move to the next portion of our presentation, which is our main speaker. Tom?
Okay, I'm excited to introduce our speaker for today, Helen Friedman. He's an artist and astrophotographer who records our neighborhood star from his backyard in Buffalo. He received awards in 2020 and 2019 in the Astronomy Photographer of the Year contest hosted by the Royal Observatory Greenwich. And his solar portraits have been featured in the exhibition of the same name at the National Maritime Museum in Greenwich, England. Those are pretty amazing photos. when we get closer to the Q&A session, I'll post the links in the chat just so everybody has them. And his work has also been the subject of books, lectures, a TED Talk, and featured on NASA's popular website, Astronomy Photograph of the Day, the APOD. His collaborative exhibition with photographer Douglas Levere, Fire and Ice, premiered at SEPA, which I had the hardest time finding out what SEPA stood for exactly. And I believe it's still Center for Exploratory and Perceptual Arts Gallery. And that was in 2015. And it traveled to the Photo Red Eye Gallery in Santa Fe and the Kresge Gallery in New Jersey. And a solo exhibition of sun photographs, Into the Light, was shown at the Palm Court Gallery in Orange County, California. And by day, Alan is president and CEO of Great Arrow Graphics, Buffalo, New York-based greeting card publisher. And I'll post the link to that also. He's a research associate at the Buffalo Museum of Science and the director of the Buffalo Astronomical Association. So I hate saying this, but with further ado, please take it away, Alan.
Okay. Let's see if I can get my screen shared correctly. Okay, is that looking all right?
Looks great.
Good. So thanks a lot for giving me the opportunity to talk tonight. It's been a long COVID hiatus, and I've been asked to do a number of talks, and I actually have not done one. This will be my first, although I've, like all of you, had 5,000 Zoom meetings. I haven't really shared my screen in any of them, so I'm looking forward to this. And Adriana, that was a great talk to precede me. I really enjoyed it. Thanks for that. So I'll take you through a little bit of the history of the work that I do. Most folks who know anything of me know me as a solar photographer. It's what I've done primarily for the last 20 or so years. This is a view of the sun from my backyard with a lovely solar halo. It's a little bit of an idyllic and idealized view, though. My backyard actually looks more like this, where we have a lot of transits of power cords in front of the sun. It's far from an ideal site. There's all kinds of problems. There's clouds. We're under the jet stream in Buffalo much of the year, much of the time. So we're often observing during sucker holes like this. And then, of course, there's this, which makes my observatory difficult to use much of the year. And this is my observatory. I don't have a dome. I have a mount that lives in my backyard all year long. It serves me well, but it isn't certainly an ideal platform. So it's all about what you can do 50 feet from your back door. This is not my observatory. This is the Nordic Optical Telescope in the Canary Islands, which in the 1990s produced the most detailed view of Saturn ever taken from Earth. And 15 years or so later, amateurs all over the place were exceeding the resolution of this image through an amazing process called lucky imaging. I'm sure many folks in your club, many folks in my club get involved in this. It's really opened up a world of possibility for taking pictures of the solar system with modest instruments. But a question we might have is like, what's the point? Because there are obviously closer cameras than those in our backyards, Cassini being a great one, who takes images of, or did take images of Saturn, unlike anything that we can see from Earth. I'm sure you're all familiar with that repository of images. It's one of the most breathtaking, and I think rivals the Hubble for the excitement of the imagery that it produces. And certainly there are lots of cameras pointed at the sun from outside of Earth's atmosphere, a solar dynamics observatory maybe being the most recognized and the most brilliant in terms of the imagery that it's able to record in many different wavelengths. So why do we bother doing this kind of stuff? I mean, what can we do? I live in the city of Buffalo. Can't really observe or take pictures of dim fuzzy stuff from where I live. We have a rural observatory for the club, which I do enjoy, but mostly because of the way my life is and how busy it is, what I can do from my backyard is what I have learned to do best. So one of the things we can do is just to try and record amazing things that our eyes can see that are very difficult to get from a camera. This is a recent version of an image that was actually my first published image was in Sky and Telescope, I think in '94, which was a double exposure trying to record the daylit and earthlit, the sunlit and earthlit phases of the moon. And it's something that our eyes with their beautiful adaptability are able to see at the same time. But if you try and take a picture of it, it's really difficult. And there's no way to have the dynamic range to record both at the same time. So this is double exposure, trying to capture that beautiful April 1st crescent moon, which is so, so stunning when we see it up high in the sky. For many years, I dabbled in high resolution lunar imaging from my backyard using my 10-inch telescope. And it was something that I really enjoyed doing. I haven't done it in a while. I also spent quite a bit of time imaging the planets, also with a 10-inch telescope, which when I first started doing it was a large telescope, but these days 10-inch isn't so large. And when it comes to resolution, we know that aperture always rules. So I haven't done this much of this. Most of this work is from the first half of 2000 to 2005. Of course, Venus with its beautiful subtle cloud belts. And this was a summary of 6 years of observing Saturn from the backyard. The edge-on image at the upper left was actually created when Saturn in that apparition went edge-on. It was too close to the sun and we weren't able to photograph it or observe it directly. So what else can we do? We can get out and enjoy special events, fleeting moments like the transit of Venus. I was fortunate to be able to witness the first transit of Venus in our lifetimes in 2004. And for the second, I was a guest up on Mount Wilson, which was really a highlight of my observing time. I had a friend who was the superintendent of Mount Wilson at that time, and I was able to stay up there and observe from that rarefied location. These are always fun. I've observed the space station passing in front of the sun quite a few times. This was the most recent last year, and actually one of the best. I finally learned how to prepare for it and make sure that my shutter was fast enough that I was able to get a sharp image, and it came out pretty well. Always exciting to see at 2/3 of a second. It's a real thrill to capture. This is a stable of astrophysics telescopes. I have a number of other telescopes as well, but these are my astrophysics beauties. I've been very fortunate to be able to own a number of them. They're breathtaking instruments. Also seen in my backyard. To the left is a 6-inch. Next to that, heading right, is the stowaway, the 92mm stowaway, the 4-inch AP Traveler, and the 10-inch Mac Cass. And this is my little AP stowaway, which I use for the bulk of my work. It's 92mm f4.8, so it is one of the smallest telescopes with a 90mm H-alpha filter on it. It's probably the smallest 90mm H-alpha telescope around because it's so short and portable. And here it is riding piggyback on the 10-inch Mac. My little solar telescope is called Little Big Man. Here I am posing in the backyard with a wonderful solar cloth made by my wife, utilizing silver lame to create a little bit cooler enjoyment underneath that black cloth underneath, with the concept that everyone looks better in silver lame. And here is little big man the way he's usually set up on the tube rings for my 6-inch telescope. This is my 900 mount. I've actually swapped this out for a 1200 mount that I bought many years ago with the idea that I would take it to star parties. But as I get older, the idea of taking the AP 1200 to star parties gets more and more in my dreams and not in reality. So I've set that up. And here is my travel case, very small, holds the telescope, solar filter, blocking filter. There are 3 cameras in there, a bunch of tele-extenders, and an eyepiece and a diagonal for visual observing. And it fits underneath my seat in an airplane. So this is a really portable setup. And it allows me to go on adventures. As you get older, going on adventures with big telescopes gets harder and harder, but this is me just south of Buffalo, preparing to view a partial solar eclipse. But this was a different solar eclipse, which happened in June. I don't think it was visible where you guys are, but it was quite nice in Buffalo. The best, it was a partial everywhere in the United States, partial annular eclipse. Best seen, I believe, from northern Michigan, but it was quite good from Buffalo. And this is on the rooftop of my office building. I had thought of doing this at the Buffalo Museum of Science, where I'm a research associate, but with COVID and with the crowds that were going to be there, I decided to do it by myself and got up and went to the office early. I don't ever get to the office early, so it was quite a surprise my staff to see me when they got there. And this was the eclipse that was in 2014, which I was observing just south of Buffalo, with the massive sunspot that was right in the center of the disk at that time. It was really a great event. And this was the eclipse from 2017, I believe. Where I went to Kentucky. This was my first total solar eclipse. And it was just a marvelous event. I'm sure that many of you have been to total solar eclipses. If you haven't, what everyone says is true. Just be sure to get there and do it, and then you'll become an eclipse chaser. We will have a total eclipse lasting 4.5 minutes where Buffalo will be on the center line in 2024. And it will most likely be cloudy because it's going to be in April, but what an exciting time that will be. I love this image. This was right before totality. You wouldn't know it from the brilliant sunlight, but that is the NASA observing plane that passed overhead, and the reflection in the camera shows the phase of the eclipse, which was quite close to totality at that point. And I didn't do too much photography at this, and there's a million pictures of it. I really wanted to observe it, but I couldn't help it but take a couple right before totality. So we can also do kind of educational images and try and explain what it is we're looking at when we see the sun. This is obviously an attempt to show the chromosphere versus the photosphere. Photosphere on the right with its sunspot, and the chromosphere on the left, showing the prominences and the active regions as seen on the atmosphere of the sun. And here are 2 views of the chromosphere on the left in hydrogen alpha, on the right in calcium kaline. This was obviously taken when the sun was very active. And my subject tonight is really about what do we do when the sun's not active. Then the pictures that we take look something like this. This is a variation from earlier this year of the image before it, showing an almost featureless solar disk in hydrogen alpha on the left and calcium kaline on the right. So beautiful, just not active. This was that magnificent sunspot of 2000 2014, which I had the ability to observe many times as it passed from left to right, and different wavelengths and different methods of processing. I actually was able to show these. There was the, I can't remember what it was called, but there was a version of an astronomy fair in Phoenix that year. And shortly after this sunspot made its rounds, I was able to observe it rotate across the field of view in calcium K line. It was a stunner, really beautiful big one. This is kind of what it's like to look through my little big man with the hydrogen alpha filter in 90 millimeters. There's a wealth of information to be seen, and it's just a spectacular sight, both visually. I always start every imaging session with some visual observing to try and get a sense of what the story of the sun is that day. Here's some video showing you what it looks like to look at the sun in white light. Unfortunately, white light is one of the weakest things to do when the sun is at minimum. There just aren't a lot of sunspots. I think last year we had 270 days without a sunspot. It is getting better, but if you have only a white light filter for your telescope, then solar minimum is going to be a quiet event. This shows you kind of the vagaries of seeing in Western New York. Reasonably good, actually. And once I evaluate the sharp frames in this video, I'm able to get a pretty crisp view of the solar surface, this taken with my 10-inch telescope and a full aperture film white light filter. It's something I love to do when there are sunspots of good size. I haven't done this in quite some time because there haven't been many sunspots of good size. This was one of the first awards I got from the Astronomy Photographer of the Year Awards. It was an APOD as well. Just a beautiful big spot. And this is what you get to do when you have a friend who lives in Arizona, who shares his data with you and lets you work on a joint project. This was with Randy Shivak. He captured this with his 9-inch telescope, and I was able to process it. So this is a kind of a traditional rendition of the solar story in hydrogen alpha. And some of you may know that I've spent quite a bit of time experimenting with ways to process solar images so that they tell a different story every day, and a compelling story, a true story, an accurate story, but by inverting the surface and doing other things, it's possible to create interest and understanding of some of the depth of the chromosphere that's sometimes hard to get in the more traditional view. This was an image taken in the last minimum in 2009, which looks very much like what the sun looked like last year. And I was playing around with it and getting bummed with how there were no details visible. And I don't know what it was, but I just hit invert and experienced the different view that you get when you take the image and reverse the tonality so that light is dark and dark is light. And it set me on a path to explore this over the years to try and just tell the story of the sun in a way that is compelling. This image got quite a bit of press the following year in 2010 when I released it. It was shared quite widely. But it was very controversial at that time. There were, it's a question of whether it makes sense to invert the tonality and show sunspots as white instead of black. But I felt that just being able to see these filaments in negative really you're able to appreciate their depth in a way that's harder to do in the traditional non-inverted view. But again, these were quite unusual when I did them. There are quite a few more people utilizing this processing technique at this point in time. And these were all taken from 2012 to 2014, 2015, when the sun was in its last maximum phase. You see big prominences and lots of active regions. Here it is in calcium K-line. I'm fortunate to have the ability to have a summer camp for a very rare calcium K-line telescope that belongs to a friend of mine who doesn't do imaging at all. And neither of us can see at this wavelength of light. I've actually had cataract surgery, and now I can just make out the violet circle through this, but all of this detail I cannot see. The camera sees it quite well, though. And here is what the calcium K-line sun looks like. This was last year. Obviously, quite a difference. Still beautiful, but completely uniform, featureless. This is in hydrogen alpha. And just slowly, the sun is beginning to return to activity. We're getting some large prominences. There was a beautiful one last week, which I hope you all got to see. It came because have been in Vermont for the week without a solar telescope. So I hope you all appreciate the beautiful prominence that came because I couldn't look at it. And here is calcium K-line from just a week ago. So starting to get a little more activity in its return to solar max. Of course, during solar minimum, prominences don't stop, and prominences are just my favorite thing to photograph. They're different every day, and they really tell a different story of the sun every day. And they vary in scale too. Something that is very difficult to do in any other astronomical observing or photography passion. Galaxies pretty much remain the same size, excuse me. Variable stars occasionally burst. The planets pretty much remain the same size. They do vary somewhat, Venus most appreciably, but prominences can be huge or small, and they give us something, quite wonderful to photograph. And a really large one, you don't have to have perfect seeing for it because they're so large and dramatic. These are a few prominences taken with a very standard rendering where the sun has a black occulting disk in front of it so that you can appreciate the subtle shapes in the prominences and the feathery areas, which with a white background of the sun is much harder to appreciate. So this method of showing the sun with an inverted chromosphere just felt natural to me when I was working with these types of images. Here's what it looks like with the non-inverted disk. There's such a huge dynamic range difference between the brilliant disk of the sun and the much fainter prominences. I just had a hard time, I felt, capturing what the sun really feels like through the eyepiece. So exploring with inverting the disk made for, to me, a more natural transition, and I process many of my images that way, but not all of them. Here is a magnificent prominence with the black occulting disk, and then with the disk of the sun, the chromospheric detail added in. This was an amazing prominence. It went on for several days. This was the next day. And I photographed it and then experimented with the processing in a few different ways here with the disk not inverted, and but the sky brightened and the prominence dark. I'm not sure which one I like the best, but I think prominences are among my favorite subject to photograph. This image was the solar winner in the Astronomy Photographer of the Year Awards in 2019. And this image was shortlisted this year. It will be in the exhibition that opens at the National Maritime Museum in Greenwich. I believe it's September 18th. the awards will be announced the next day. And this was a very nice large prominence that was earlier this year during a very minimal period. One thing I noticed with prominences during minimum is they tend to be more feathery. You rarely get one of those massive, heavy hedgerow prominences at this low activity time. This was taken just a couple of weeks ago, and this just last week. So another fun thing about prominences is they tend to look like stuff. If you enjoy seeing shapes in clouds, you'll love solar prominences. This one, to me, just looked like a cormorant catching a fish. And this one, of course, it's obvious what it looks like, right? Really hard to do this with everybody muted, but I hope you enjoy this Roadrunner. And this one is one I took a long time ago, but when I saw it, I knew exactly what it looked like. And when I've given talks with a live audience, I always ask what this looks like, and everybody will yell out something, and I get to say, no, wrong, it looks like this, which is, of course, Sasquatch. So another thing that's fun is that prominences change quite rapidly over time. And some are very active and over a short period of time collapse back into the sun. They're either blown out into space by the solar wind. Here is one that collapses from the huge gravitational pull of the sun over a fairly short period of time. I think it was a half hour to 45 minutes. And it just disappeared into the back into the sun. Another fun thing to do is to collaborate. There was an operator from Big Bear Solar Observatory who was part of the Solar Activity Group on Facebook, and he was able to share this data from the BBSO, which was a very high resolution image of a very small sunspot, and he left it out there for other amateur astronomers to process. And I took a whack at it and came up with this. Inverting it gave a real difference in the ability to see the depth going on in this magnificent view of the chromosphere. And it was actually selected as an astronomy picture of the day in 2015, which was great fun because it was the first APOD for Big Bear Solar Observatory since this one in 1997. Just to give you a sense of where astrophotography has gone in this short, what is it, less than 20 years. So I do a bunch of different things. I'm a fine artist by trade. This is the show that Tom mentioned that I had with a friend of mine, Douglas Levier. And one of the concepts behind this show is that the sun, if you hold your arm out in front of you, you'll find that the sun is about the size of your index finger nail, which totally by coincidence is the same size as a very large snowflake. And so we put together this show called Fire and Ice, which was a collaboration of images of the sun paired with images of sunspots. It was great fun. This was a collaboration with a musician who is from Northern Ireland, who actually mapped this image of the chromosphere to music using a kind of electronic mapping system to create the following music. I hope you could hear a little bit of that. It goes on just that way for about 15 minutes, so I'll just share a little bit. I love collaborating with musicians who, a number of them have seen my images and requested to use them in their musical albums. This was a small band called Dystoria, which is based in Astoria in, I don't know how I get rid of that little thing. They're based in Astoria, which is the neighborhood my dad grew up in, New York City. And I made this available to them in exchange for 2 tickets to their first appearance on Saturday Night Live. I'm still waiting for that. And this was a book that I did as a collaboration with a New York artist and the North Face company of Japan called Nanamika. And it was a show that took place in Tokyo, which was very neat. And I didn't get to go see it, but I did get one of these yellow jackets, which was very cool. And unfortunately, it doesn't fit any Western body, but my kids can wear it. And this is a picture of a very famous solar photographer, Thierry Legault. Some of you may know him, underneath my silver lame cloth, looking through Little Big Man at the Northeast Astronomical Forum. And sometime very soon, I hope we will get back to doing this stuff, which I love more than anything else, which is sharing the views through Little Big Man with the public, because you never know who that kid on the back of the pouch is going to be, and if they will be the next Stephen Hawking. So it's always a pleasure. Hopefully we'll be back doing this kind of work very soon. In the meantime, when you have nothing to do, I hope you'll visit Averted Imagination, and I'd love to show you around our neighborhood star. There are quite a few pictures there. And that's the end of this part of the talk. So something we can do, and you should let me know how the time is going. If you'd like to see a little bit more, I do have an image in Photoshop that I'd be happy to share with you, or we can do questions and answers that might have been longer than what you anticipated. So
I'd
guys
say
let me know.
go ahead, Alan. I think people are dying.
Yeah.
Yeah.
Okay, let's do it. I think I have this open here. Let's see if we can see it. Is this showing up? Am I still sharing?
Not at the moment.
Okay, let me go back to Zoom and share my screen. Okay,
There we
that should
go.
be better. So this is an image taken earlier this year, and I'm going to move everybody's pictures here so that I can see what I'm doing, and just show you a little bit about how I process an image. So I'm one of maybe 3 astrophotographers who use a Mac to capture images. And the software that I use has not been available for quite a few years. It's called Astro IIDC. And if any of you were Mac users who bought the whatever they call it, a golden key or whatever, to be able to keep using it, it's a fabulous piece of software, but it can't be purchased any longer. So I'm not going to show it to you. Much of that stuff is done on a PC, and I'm sure you all have ways of doing it. But after I capture the images and I stack them, many people would use either Registax or Astro Stacker to stack them. I bring the files into Photoshop where I process them. And I'm just going to show you a little bit of some of the possibilities. So this was a nicely detailed, excuse me, relatively small but well captured prominence. And this is the simplest way to record it, which is to show the prominence. Obviously, the disk of the sun would be white here. Because the prominences are so dim, compared to the disk, in order to get the prominences properly exposed, the disk of the sun will be a brilliant white. I've already, that file is no, oh, well, here it is. Okay, so let's see if we do this. No, that's color. Let's try this one. Yeah, so now if I just have that, I think if I take this away, oh, I'm going to close a couple of these. Excuse me a second. I got a lot of layers in here, so bear with me a minute. Boom, boom, there we go. So this is very much what the raw data would look like. And actually, if I go to the file, I think I can show you what the capture looked like. Let's see, what's the date of this? This was June 11th. Let's find the file that was used to create this. And I'm pretty sure I used the first one. So I can play this and show you what the quality of the data looks like. Usually the earliest stream that I take tends to be the best because the seeing tends to decline as the sun gets higher up. As you can see, there's, if you're all familiar with looking through a telescope, this is pretty good seeing from my neck of the woods. And the software that I use will evaluate this video and it will select for me the best frames, ordered from the best to the worst, and it'll say, how many do you want to select? And I'll usually take about 300 frames, the top 300. And I will then align them on a few different spots, here, 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 maybe here, and then merge together the separate stacks aligned on the different areas. And that'll get about the sharpest possible file for me to begin working with. And it will then wind up looking something like this with the white disk of the sun. So the easiest way to do this first is to put this occulting disk in front of it and see how much easier it is to see the detail. It's basically like shutting off the white light at the observatory so you can actually see something through the eyepiece. It does the same thing to put that occulting disk in front. And the only thing that I like to encourage people to do, if you're going to create one of these, create a smooth edge. Don't just use the magic wand and make a ragged disk of the sun. It isn't very realistic looking, and it's just not very pretty. You can use the circular marquee to create this shape. And it's a very nice way to present dramatic prominence. And should have brought a glass of water. Nothing is older than yesterday's prominence. So it's always good to have a way to be able to process these things quickly if you want to send them to space weather or even share them with your friends in the club. Having a picture of today's prominence is a good way to go. So the next thing that's possible is to add in, let's see here. There's so many layers here. Which one? Oh, here's one. Let's get rid of this. I can show you. Oh, thanks, Adam. That's good. Here's the non-inverted disk of the sun. And here it is inverted. So this is a monochrome version of the image, much like some of the others that I was doing. And this, so here's a little trick. You might have noticed that of obviously the sun's background, because we're only working with maybe one 1/100th of 1% of the sun's energy, the sky around the sun is always going to be black when we get this data. And at some point, I just felt that the sun we observe during the daytime, so do we have to only show it with a black background? And often I will lighten the background. It gives me the ability to tell the story slightly differently. And one of the ways you can do it is to create a gradient. And I'm going to show you this little trick here. This is something I often don't show, but I think you guys are sitting patiently and you should see it. If you work in Photoshop, if you take the gradient tool and a new layer here, and you drag the gradient tool from here, say to here, and create that gradient, now it covers the entire sun, right? But if you change this layer from normal to screen, look what it does. It creates a a kind of lightened gradient that allows the prominence data to show through. And I use this a lot. And you can manipulate this gradient at this point to do different things. And in this image, it's also colorized. So where is our colorized gradient? It's one of these here. I believe it's this one. So these color layers are creating the color in the background. These are both layers which are applying, you can see they're labeled color. They're only applying color detail. And then this is a color version of the disk. And this is pretty much the finished image here, which I chose for that day. And I often just move from one type of colorization to another, just trying to keep the story interesting, like a journal of the sun. As an artist, the color is not, I mean, sometimes I'll make a calcium image that's blue or purple, but sometimes I'll make it gold as well. And I think as long as you're telling the story accurately and not painting into the image, but using the actual data from the sun, that with an explanation that these variations are fair, and they help to make a compelling image. And the more compelling the image, the more people will look at it, the more it will travel, the more it will get published, and those are goals. So I think I'll stop my share now. And if anybody has any questions, I'm happy to answer.
Thank you, Alan. That was great. Yeah, if anyone has a question, please put it in the Q&A. There is one question that popped up in the chat, and that was if you had any guesses as to the strength of the upcoming solar maximum.
Well, there's a lot of discussion about that, and I've seen some forecasts that expect it to be a not very strong maximum. I don't, I mean, I follow spaceweather.com as much as anybody, and read most of the articles that Tony writes and puts on. I think the jury is still out about that, and hoping that it will be a strong maximum, but I've heard of it both ways. Solar science and solar physics is very complicated. And as you might have heard when Tom introduced me, I'm a greeting card publisher. That's what I do in my day job. So if you want solar physics, best to talk to a solar physicist for the best information. I think I have, a rough idea of much of the science behind what I do, but I'm often not the best person to ask real technical science questions.
Tom Plakas, you've got a question? Let's see. You're unmuted, but we're not hearing it.
Unmute yourselves to ask questions is good with me, if it's okay with our moderators.
Yeah, definitely. Let's see, I just need to enable it. Let's see, for Tom Curry.
What does this question mean? Did you try and make maps of BR blue to red color?
I'm sorry, that was a post on my part that I thought I had something copied. I pasted the wrong thing. Let's see, Tom Curry, you should be able to ask your question.
Well, there's a question here. What do you find to be the optimal time of the morning between sun gaining enough altitude and the seeing deteriorating? It's a great question. It really depends on your local setting. As you can see, I have a backyard in the city. There's a lot of greenery, but once the sun gets up, I mean, for me, 9 o'clock is a great time. The sun's not too visible before 9 from my backyard. Usually by 9 o'clock, if there's good seeing, it's still pretty good. And I find that by 10 o'clock, I notice the deterioration. Later in the afternoon is also good, but it's not so good from my backyard. I mean, I do travel with my solar gear too. If there's something very exciting and I want to be able to give it an afternoon shot, I will take my more portable equatorial mount out and find a place where I can view it later in the day. But between 9 and 10 is when most of my captures are done. You know, I live in the city. The roofing material in my area is mostly asphalt shingles. And by the time they heat up, they radiate a lot of heat. And in the winter, even though the sun is pretty low, there's usually only about, I'd say, maybe 45 to 60 days when the sun is really too low to catch from my backyard. There's a lot of weather, you know, bad winter weather that makes it hard to observe. But the heat escaping from the old houses in my neighborhood, which was mostly built in the 1890s to 1910, there's a lot of poorly insulated roofs, and that escaping heat is terrible for the scene. So it's rough, but you know, if you want good seeing, you move to Arizona. You don't live in Buffalo.
Okay, let's see, Tom Curry doesn't have a microphone on his computer, so was in your last example used in the processing info, these full frame or stick?
So do you mean the size of the capture that I'm creating? I have a bunch of different cameras, and the camera that I used for the more detailed views of prominences, those are, well, I should start off with the capture setting. The little big man has a focal length of 450 millimeters. For the sections of the solar disk where I'm enlarging a prominence area, I'm using a Botter full, what the heck was it called? FFC, flat field converter. It's a beautiful fluorite teleextender, which gives me somewhere around 1700 millimeters in focal length. That's what I'm using there. And I'm using one of my smaller cameras, a 2 megapixel streaming camera, which I can't remember the exact pixel size, but at the end of the day, it makes a picture about 24 inches at 72 DPI. So it's, I can't remember how many, well, it's 2 megapixel capture. The full disk images, I have a 6 megapixel camera, which has a much slower capture rate, I think 11 frames a second instead of 30. This is old gear too. I haven't reached the potential of the gear that I have, so I have not bought a new piece of astronomy equipment in almost 20 years. The camera, actually, the cameras are from a company now called FLIR. It was Point Grey Research. They're marvelous cameras, and they were loaned to me when I was doing, you know, I was helping them promote their cameras. And they're very good, and they've lasted me a long time. I think they're probably much better cameras to use now, but not that many will work with a Mac. So I still use those same things. And I have a computer which runs the old Mac operating system, which if any of you are Mac users, you might know that they killed QuickTime sometime about 2 years ago. So the next time I get a computer, it will not run my software, nor allow me to capture full resolution QuickTime movies. So I may retire then and pass the gauntlet to someone younger to do this work in a beautiful way. There are so many people doing fabulous solar imaging now. It's just remarkable. So I appreciate you giving me a chance to talk, but boy, there sure are a lot of great people to talk. I'm sure many of them in your club.
Okay, Tom Curry likes that answer. I think that answered his question he had.
Which, by the way, I'm seeing Tom Polakis' picture there. I hope that's the right way to pronounce your name. I know we're Facebook friends, and these planetary images you've been doing in the last few weeks are fabulous. So glad to be able to tell you in person.
That's a long A, Polakis. It's close. And he puts a thank. Yeah, I'd give a shout out to Tom also, because he helps me come up with ideas for speakers, and he recommended I contact you to come and talk to us. So really happy you were able to come and give a talk here. yeah, it's amazing images that you do. And sharing some of the techniques you did right there is kind of interesting too. And for everybody on the call, I did post 4 links to Ellen's work. If you can copy those, or you could just Google Ellen, and those links will come up. They're, yeah, very, very beautiful photos, and some nice interviews. They do the interview of some of the people who submit photos to the contest, make it a more personal human interaction.
It's a really fabulous event. If you haven't ever submitted work to it, I'd really encourage you to do it. It's very competitive, but it's a beautifully run competition. I think they get about 5,000 entries. This past year was the first year they ever charged a fee. And it was, I believe, £10 for 10 images. And the exhibition that's mounted is spectacular. My family and I went to Greenwich for the awards in 2019. And I was just so impressed with it. It's really Greenwich is a beautiful place. I hadn't been to London in a long time, and I was a thrill that I won that year. I had no idea that was going to happen. I just wanted to see it, and it's
Oh,
one of the
wow.
best events. It's nice to win. I mean, that and 25 cents gets you on the Staten Island ferry, as they say. But it's really really well done. The whole thing is great.
Okay, well, I don't
Well, thank
see any more
you.
questions. Go ahead. You have another comment, Alan?
No, that's it.
Oh, okay.
It's very exciting to be here, and nice to stay up late and to see you all. It's been a long time since I've been in Arizona, but I love it out there. I collect
Great.
Navajo art, so it's a great place to go.
And we're very happy to have you give us a presentation there. We're pretty excited to have you. Thank you. I'll turn it back over to Gordon.
Yeah, I'll jump on in here, Alan. Yeah, I'll certainly mirror Tom's comments. What a great presentation, fantastic images. If you were sitting in this room with me, it would sound like 4th of July fireworks with all the oohs and ahs that I was doing in here. In fact, I think I'll have to clean the nose prints off the monitor as I was getting down and looking at the detail. Fantastic pictures. So thank you, Alan. Thank you very much for sharing those with us.
Appreciate that.
And Adriana, thank you again for your presentation. Excellent example of a member presentation, and I certainly look forward to seeing more from you. So remember, guys, next month on September 17th, Dr. Alan or Nathan Williams will be talking about the Mars helicopter. So, and remember, guys, think about the elections that are coming up in a few months. If you want to get deeper involved in our club and help in the running of it and the leadership of it, my gosh, let me know, okay? And that is it for this time around. I will give the usual countdown. If there's any, let's see, there was one more chat. Let's see what the chat was. And that was that a question maybe? No. All right, so everybody, 3, 2, 1, bye.
Bye, everybody.